those 4 things that you're going to need to know how to do, and this is in College Board from the AP exam in College Board, they are find zeros. I would make this little list, intersection points, definite derivatives. I don't know why I didn't pluralize that. So we can find definite derivatives or definite integrals. Okay, we're going to talk about some additional things. One thing that I found very helpful for my students is storing values. And you're also allowed to use your calculator for like multiplication, division, subtraction, addition, and graphing. So, but the 4 basic things that are probably going to be new to you are finding zeros, intersection points, definite derivatives, and definite integrals. And we're going to talk about how to do each of those with a few examples. Okay. If you don't have a calculator with you today because you forgot, despite my many emails and reminders, please make sure you're maybe sitting next to someone, or you can maybe borrow a calculator if you're in a room with someone. That way you can go along with us. It's a really hard process to do if you don't have a calculator with you. Okay, so this is example 1. It says, given y equals sine of x minus x squared plus 1, find the slope or slopes at the point where y is equal to 0. Okay, so what the question is asking us is it gives us a y equals. It wants us to find the slope at a specific point, but it's not giving us that x coordinate. It's telling us we want you to find that slope or that derivative at whatever x coordinate causes this equation to be 0. So the first thing you would do before you touch a calculator is you would set that up. We would say 0 is equal to sine of x minus x squared plus 1. Now, the reason this is calculator active is because we don't know how to solve that by hand. We've got trig and like a quadratic in there. We don't have a way to factor this or solve this by hand. So this is where we would use a calculator. Okay, so what we're going to do if you grab your calculator is we're going to go to y equals, that should be on the top left. And we're going to type this equation into our y equals. Again, make sure you are in radians. Make sure you did that reset on your calculator. So we get sine x minus x squared plus 1. We're typing that exact thing into our y equals. Make sure you close the parentheses on your sine of x. It's going to open a parentheses before you put that x in. Make sure you close it. And then minus x squared plus 1. Okay. Now, because we reset our calculator, if we go to graph, our window is going to be the standard window, which means it's going to go from -10 to 10 and -10 to 10. We can adjust this window however we like. I wouldn't recommend clicking zoom in, and I wouldn't recommend clicking zoom fit. Those are not really recommendations that I suggest to be successful on this. I would recommend adjusting your window to specific numbers that you think are going to work. So looking at this, each of those tick marks is 1. I'm going to adjust my window. So I'm at maybe, let's go -3 to 3 and -3 to 3. So just to clarify, I went to window. This button right here is window. And then I just adjusted my X min, X max. I didn't adjust my scale. That means that everything's still going to be in ones. And then my Y min and Y max. It's kind of a guess, but I think it'll work pretty well. I press graph again, and we're a little more zoomed in, which just makes it a little easier to look at that graph. You don't want to click zoom fit because then it might adjust your window into a thing you have no idea where you're looking at. Okay. Now, what we want to do is we want to find those zeros. These are the things we want to find, are those zeros. So some of you know about this trace button. And if you click trace, it brings up a little cursor. Okay. And with this like left, right arrows, you can adjust where that cursor is. And some of you are like, oh, okay, so I'll put it right over here to this 0. And I don't know, that's pretty close. The cursor used on trace is going to be an estimation. It's not going to give you an exact value. We have a way to get an exact value. Please write this down. So to find a 0, what we're going to click is we're going to click second calc. Okay, or that's that same button as trace. So you're going to go second calc. And then you'll notice the next line has a lot of options. So it's got, value, 0, minimum, maximum, all that stuff. We're going to go down to 2 where it says 0. And you can either use your up down arrows or you can click on the number 2. Okay. And now the question says left bound. So what it wants you to do is it wants you to move that cursor so it's just a little bit to the left. I'm going to choose this one that's over here on like the right-hand side. So everybody needs to choose the same 0, otherwise you're going to get different values. So when it says left bound, it means move that cursor just a little bit left. So I'm going to move that cursor just like a little bit left of that 0. Okay, because the question is left bound. And then I'm going to press enter. And then the next question is right bound. So I'm going to move that cursor just a little bit past, so it's a little bit right bound. And then I'm going to press enter again. The next question is guess. You don't need to move your cursor at all. You can just press enter. And it's going to give us our exact 0. You'll notice the y value here is 0, and it gives us our x value. So we can go ahead and write that down. X is equal to 1.409. Now, if you're looking at that number has a 6 after that 9. So you might be saying, Ms. Toshner, why didn't you round? Because we don't have to for calculus. We can do what's called truncating. So you can just chop off that number after the thousandths place. You need 3 numbers after the decimal. So you always in calculus, anytime you're using a calculator, you need the thousandths place. It will be wrong if you only go to the tenths place. And if you go past that, you might just mess up your number, so it's not worth it, okay? And Ms. Toshner suggests truncating instead of rounding. It just takes the guesswork out, and you are not required to round. If you round wrong and you mess that up, then your answer is wrong. So you're allowed to truncate, meaning just chop it off at that value, okay? But that value is not our entire value, right? Even the number shown here, 1.409624, that's not even our entire number. Our entire number has like infinitely many numbers after that decimal. Okay, so what we want to do is we want to store the entire number so that we can use it later to find this derivative. Because what we're trying to do is find the slope at that point. So now we're going to talk about how to store. This is a complicated process. This is hard to look up and find. So make sure you're following along. If I go too quickly, please let me know. Everybody needs to have this on their screen. This should be what's on your calculator screen right now, okay? To store, so we talked about how to find a 0. To store, what you're gonna do, and this is a little bit confusing the way I'm gonna describe this. So again, unmute yourself if you need me to slow down or repeat. When it has this on your screen, you're going to press this xt theta n button. And what's gonna happen when you press xt theta n is that it's going to give you x equals x. So I'm going to write that down, x equals x. And then I'm going to press enter. And what we've done is we've temporarily stored that entire number with all of those numbers, even after that decimal not shown, we've temporarily stored it into that xt theta n button, but it will only remain there temporarily. So what we now need to do is we need to go second quit, so that we're back on our home screen. Okay, so I'm back on my home screen. Then we're going to press that X button again, which is that xt theta n button. And then a button you probably never used, which is right above your on button. If you look down here, there's this little STO button. That STO is our store button. So we're going to press X and then STO. It's going to bring up a little arrow. And then another button you've probably never used is this green button up here, which is our alpha button. I told you this one was long. We'll get a couple things of practice for this. So we're going to press alpha. And now you might not have ever noticed there's a whole alphabet of green letters on your calculator. We're just going to store this into A. So it's right underneath alpha. It's the same button as math. We're going to store it into alpha A. And then press enter again. Now, you'll notice even this decimal is longer, and this decimal keeps going, and it's the whole calculated value. So it's exactly the right number. On the AP Calculus exam, your final answer has to be correct within a certain very small error. So if you use in your calculator, if you only type in those 3 decimals, that 1.409, your final answer might not be correct to the correct decimal place. Okay, so that's why we're going to use store, and it's going to make it easier so we don't mess up typing. Okay, so now we've got that stored in our calculator. Okay, so we've talked about how to find a 0, right? Second trace. We've talked about how to store. X equals X is how we start on that one. Next thing we're going to do is how to find a definite derivative. You can only find a definite derivative on your calculator. So for example, if you were trying to find what is the derivative of x cubed, your calculator is not going to give you 3x squared. But if you wanted the derivative of x cubed at 2, your calculator can do that. Okay, that is one of the things that you're allowed to do on certain sections of the test. Okay, so to find a definite derivative, you should be on your home screen still. We've stored that into A. Now what we're going to do is we're going to press math. So that's that same button that we just did for alpha A. We're going to press math and it brings up this menu of options. And we're just going to go to, I just click directly 8. I don't even scroll down. I just click the number 8. Okay, but you could just scroll down if you want, down to the 8th one. And then it brings up this super cool thing, which is why I fought for the TI-84. If you have a TI-83, you have to actually do some programming from here. But what you'll notice is it says D over D something, parentheses something, and then X equals, or it's gonna say an X once I put an X in here. It's gonna say X equals something. That means we're gonna be able to find the derivative at a specific point. So the first thing we need to do is choose what we're taking it with respect to. And we're always gonna take it with respect to X. So I just press that X T theta N button so that it's D over dx. Then I'm going to type in my equation. So my equation is sine of x, don't forget to close the parentheses on the x, minus x squared plus 1. So now it's D over dx of my equation. Make sure you type that in correctly. And then the super cool part is that we are going to not have to type in that 1.409 with a million numbers. All we have to put in for x equals is we're going to go back to our alpha and click the A. So we're going to evaluate this at x equals A. A is where our number is stored. So A has our entire number. So we can just do it at x equals A, and then we press enter. And we get negative 2.658 whatever. It does not matter that the next number is a 7 because we're going to truncate. Okay, here's how I'm actually going to write this though. If this was a free response question, I want to make sure we understand. So we wrote 0 equals sine of x. Let me outline in yellow what we've written for work so far. We wrote where that happens, which is x equals 1.409. I would, if I were you, write equals A in that same line. That way I can use A for the rest of the time in my calculations. And what we want to find is we're trying to find y prime of A. And again, you could write y prime of 1.409. And what we found is that y prime of A is equal to negative 2.658. 3 numbers after the decimal. Truncate is my recommendation. You are allowed to round if you want. I don't know why you would. Okay, and then that's it. That would be all the work required for this problem, sort of. There's another place where we had a value of 0, but for time purposes, we're just going to do this first one. Okay, but you would follow the same process. So if I then wanted to find, if I go back to my graph, if I would want to find the other 0, so this one over here, I would go second trace. I would go to 0, which is that number 2, right? I do my left bound, my right bound, my guess, and then press enter, and it's going to pull that up. Then I would store that value. Then I would, and you can store it into any alpha you want. Like I chose alpha A, we could have stored it anywhere. Okay. For this problem, since we already used A, you'd want to store it into like maybe B or something. And then you do your definite derivative for that one. Okay. What questions do y'all have here?
Yeah. So when I put in the like the y equals equation and went to the when I graphed it, like it keeps saying like it's not working.
Did you reset your calculator, Dominic?
Yeah.
You did second plus sign 712?
Yeah.
Okay, and you're kind of dark, so I'm not even gonna be able to see if you show me, but hopefully you typed in your y equals correctly. So you have the correct parentheses, open or closed.
Mm-hmm.
And check your mode. Is your mode in radians?
Yeah.
And it's just not even giving you the right graph?
Well, no, like when I change the window, like to -3 to 3, it doesn't graph it.
Check that your window is set like mine.
Okay. Yeah, I changed the window.
The success or no?
Yeah, it worked. For some reason, it didn't
Great.
work.
Yeah, stop me earlier, Dominic, if you have a problem, because I worry that you missed kind of a lot of those extra steps. So just stop me earlier if you have a question or a problem. I'm happy to make sure we get everything right for everybody here. Okay, I'm also recording this, so I'll throw this up on YouTube later if you guys miss a step or want to review something. Okay, any other questions? Go ahead.
Ms. Toshner, when I click Math 8, I get a completely different function than
Okay,
you get.
do you get n deriv, Charlie?
Yes.
Okay, so what you have is you have an old programming style, and I want to talk through this anyways. This is what, if you had a TI-83, this is what would come up. If you have a TI-84 and this is coming up, you can go and download like an update on your calculator. You can plug it in. But let's talk through how you would do this if you have n deriv that's coming up. What you're going to type in, please write this down, is the function first. Then a button you've probably never noticed on your calculator is the comma. It's right next to the parentheses. So it's right here is a comma. I'm trying to show it as best I can. So we have a comma right here. So you would have a comma, and then your next thing is with respect to, and then another comma, and then at x equals whatever. Okay, and then a closed parentheses. Let me do that in a different color. So in this case, Charlie, what would happen is you would write sine of x minus x squared plus 1. Then you'd put that comma there. Then you would pick that xt theta n button, and then another comma, and then your alpha a. So if you have this n deriv thing coming up, it's not as friendly as this, but it's all the same information. So the function with respect to x at this point. Okay, and then if you press enter, you should get that same number that we got. Okay. I can't really see yours, Charlie. Sorry.
I think that worked.
Okay, great. Perfect.
Yeah, that's it.
Okay. All right. Let's go on to the next thing.
So, Ms. Toshner, so just to be
Yes.
clear, well, I can ask you after class, but basically you're telling me, will you give me instructions on how to download that?
Yes. Yeah.
Because I have a TI-84.
Okay. Yep. It should just be online, Charlie. You should be able to look that up. And you might just email tech at brophy.org. They're going to have better instructions for you, or since you're on campus, you might be able to go down there and they might have a cord for you to plug it in just in case you don't have one. Okay.
Thanks.
All right, let's move on, y'all. Are there any other questions? I want to make sure I answer those questions because we just went through a lot of stuff. Okay, let's go back to our home screen, lol. Let's go back to that original like note-taking thing where we wrote down those 4 things. So zeros is something we've talked about so far. So again, that's a second trace. I'm just gonna like write shorthand here. We talked about definite derivatives. That's gonna be math 8. We talked about storing values. My little code there is going to be x equals x. And we're going to do another storing values. I know that one's really, really long, so it's really hard to remember all the steps there. So we're going to do another one here. Okay. So there's 2 more things I want to talk about that are big ideas, which are intersection points and definite integrals. So let's look at our example number 2. Example number 2 says, find the volume of the solid generated when the region bounded by y equals cosine x and y equals x squared is revolved about the x-axis. So we have find the volume of the solid generated when the region bounded by y equals cosine x and y equals x squared is revolved around the x-axis. So before we touch our calculators at all here, we should remember how to set up this equation, because if this is FRQ, this setup is where so many of the points are going to come from. So we are going to set up the bones of our equation. We're going to have volume equals, since we have this word revolved, right? We know that that's our something's pi integral something squared minus something squared. That word revolved is really important. So we're going to have pi, an integral of something squared minus something squared, and it's being revolved around the x-axis. So the x-axis means that it's going to be revolved around a horizontal line, or it's going to be revolved this way, making it a dx equation. Okay, and I'm going to put parentheses around all of that stuff. The better you can set this up in your work, the easier it's going to be to set this up in your calculator. Okay, now what we would normally do is we would draw the picture, right? So I would draw my picture. Yes, you have a calculator, so you can figure out what this looks like if you didn't know. But I have cosine x, so that's a graph that, you know, goes like this or something like that. That's our cosine x graph. And then, oh, let me do that in a different color just to keep things clear. So we have our cosine x graph. Doesn't have to be perfect. And then I have my x squared graph, which looks like this. And hopefully you know what both of those graphs look like. Okay, so it wants to take that region that's bounded by those two things, and we want to take that region and revolve it about the x-axis. So I still haven't touched a calculator. We're going to wait to really do a lot on our calculator until we can set everything up and see what we're going to try to find. Okay, so hopefully you guys remember the process from here is that we're going to put our pencil on the thing we're rotating it about. So Chase, put your calculator down. We don't need it yet. We're going to put our pencil or our pen on the thing we're rotating it about and draw to the furthest out curve. And that's going to be our R out. And so in this case, that curve is our cosine x curve. And we're not adding one or subtracting or anything like that because it's just that distance from the x-axis. So that means we're going to have cosine x is going to be our R out. Then we're going to draw from the place we're rotating it about, which in this case is the x-axis still, and we're going to draw it to our closer curve. And our closer curve is our parabola in this case. So that's our x squared. Right now, without touching a calculator, even though this question might be in the calculator section, you would have 2 points without touching it. If you mess this up, even if you start touching your calculator and get a right answer later, if you mess up the setup, you can't get any points. The setup is really important. I really want to emphasize that. Okay. Now, what we need to still find is we need to find our bounds. And the bounds are the places where these two graphs intersect one another, right? So what we're trying to find, and please write this down, this would be work you would be required to show, is where is cosine x equal to x squared? That's what I want to know. Where is cosine x equal to x squared? We don't have a way to do that by hand, right? We're not sure exactly how to do that by hand. So this is where we use our calculator. Now, right now, you've got some other stuff stored in your calculator. You've got all that stuff in y equals. So if you're lazy like me and you don't want to have to get rid of all of that and delete and erase and go back through everything, I would just practice right now, pressing second plus sign 712. If you can commit that to memory, that can save you on a test, knowing that combination. Second plus sign 712 should say RAM cleared. If your calculator goes buggy, which all tech things do at some point, you can reset it and save yourself a lot of stress. Okay, so we did second plus sign 712. Now my y equals is empty. So I'm going to go back to my y equals. I'm going to type in my two functions. So I'm going to type in cosine x, and I'm going to type in x squared. And again, when I hit graph, it's going to automatically adjust my window from -10 to 10 and from -10 to 10 because I did the reset. I would like to get a little closer into this region right here. So I'm going to adjust my window and I'm going to go, let's go -3 to 3 again. But this time, let's go y min -1, y max 2. Okay, so this is what my graph is going to look like. It's a pretty good, nice zoomed in spot. You guys will get better. Here's what my window settings are. If you wanted to check your window settings, -3 to 3. Again, the X scale stays as 1. Y-min is -1 to 2, and then the Y scale stays as 1. And there's other settings we're just not going to mess with. Okay, and our graph looks like this. Does everybody have that, or is anybody struggling with that? Need some help? Okay, so here's what we're going to do from here. We're now going to try to find intersection points. So to find our intersection points, I would write this down in your notes. We're going to go back to our, we're going to go to second trace like we did before, or second calc, however you want to remember that. Okay, same button we pressed when we were trying to find zeros. Instead of pressing number 2 for 0, we're going to press number 5 for intersect. It's pretty self-explanatory if you look at the options. So second, calc, and then intersect. Now my questions are going to be different here. Instead of left bound and right bound, my first question is first curve. Now I'm going to choose the one that is in the second quadrant. We're going to go to this intersection point first. It's usually helpful to find the smaller value first. So I want to figure out what this intersection point is. So I'm on this curve already, but I'm just going to bring my cursor closer to that 0 or that intersection point. So I'm going to move my cursor left so it's closer. Doesn't have to be perfect, just needs to be close to that one. And I'm going to press enter. And then you're going to notice right after you press enter, it's going to hop onto the other curve and it's going to say second curve question mark. And again, you just need to be close. So everybody should be in the second quadrant looking at this one right here. We're going to press enter again. And then it says guess question mark, just press enter. And it's going to bring up your intersection point. Okay, and you can check mine there. It's hard to read backwards on my screen, but it's -0.8241 something. And we don't really care about the Y value. We just care about the X value. Okay, so in our work, so far we have this stuff and the bones of our equation. We would say X is equal to, we're going to write down that value to the third number after the decimal. So -0.824. Again, I'm just truncating, but I'm going to store this into alpha A. So I'm going to write down in my work right away, A. So this is what your work should look like here. You don't need to tell the reader or the grader that you did all this intersection stuff. Okay, I'm telling you that, but you don't need to write that in your free response. Okay, now let's practice storing it again. So this time we're going to go from this screen. Does anybody need help getting to this screen? Is everybody here, hopefully? Okay, so from this screen, we're going to bring up our X equals X. So to do that, once it's on the screen, all you're doing is pressing that xt theta n. Once you press xt theta n, it's going to say X equals X. You're going to press enter. And then it has temporarily stored that entire number with all those numbers after it into your X button, into that xt theta n button. You're going to go back to your home screen. So second quit. So I'm back here. And we're going to take what we've stored in xt theta n temporarily. So I'm going to press X again. And I'm going to go alpha, or I'm sorry, second. Nope, not second. Sorry, excuse me. Store. Clear as mud. So we have xt theta n, and then we're going to press store. So it brings up our little arrow. And then alpha A. And so now that entire number is stored in our alpha A. Okay, so I can keep that in alpha A. That number is going to be stored here in alpha A. Because I've labeled what that number is in my work, on my volume equals equation, I can actually just put an A on my bottom bound now. That's actually what the rubric looks like for College Board. They use an A. Okay, if you have a question, unmute, guys. I don't always see the chat. Oh, sorry, that was not for you. It was a private message. Okay, so now we're going to do the same thing with the other one. So we're going to go and find the other intersection point. So we're going to go back to our graph. we're going to go second calc, number 5. This time we're going to scroll on over to the right one so that we're close to that other 0 that's in the first quadrant, or that other intersection point, excuse me. Press enter. So we're on the first curve, second curve, press enter, guess, press enter. And it's going to bring up our other thing. Now this is an even function or a symmetrical function about the y-axis. So it's just the positive value of the other one. But I want to make sure we can practice this and do our x equals x again. Okay, so right here, you're going to store that value. Some of you look like I've lost you. We're going to store it into our x temporarily. So x equals x. Go back to our home screen. Press X again. This time store. And this time we're going to store it into different alpha. So alpha, and I'm going to choose B, which is right here. So we get alpha B. So I've got one of them stored in A and one of them stored in B. Okay, and we have our B on top. Any questions on that so far? And again, you would need to write down in your work, x equals 0.824 equals B. If you want to use B as part of your answers up here, you have to make sure you're labeling it when you're finding it. Again, that's actually going to look legitimately exactly like the College Board scoring guidelines. That's why I suggest this. Any questions on this part so far?
Miss Tasha,
Yes, sir.
I'm just curious, can you save a y value?
You can, but it's a different process. So in order to save a y value, what you would do, Chase, is you would go back to the equation and you would just plug in an a for your x. Like if I wanted to do sine of alpha a, or whatever the function is, minus a squared or whatever, you would get a value here, then press enter, and then you can store that value into B. We'll do that another time though. Okay, but yes, you could. All right, so we now need to do a definite. Yes, go ahead.
So when you're when you're clicking the points on the graph, does it matter what side of the intersection it's on?
Nope, not for this part.
Okay.
For left bound and right bound, it matters, but for intersection points, it doesn't. You just have to be close to the correct one. Because if you are close to one and then you go to the other, it's going to get confused if there's more than one. Okay, all right. So let's talk about how to do a definite integral now. So a definite integral is going to be similar to a definite derivative. You're going to press math, and this time you're going to press 9. So again, back on your home screen, math 9. If you have a nifty calculator with the update, it's going to bring up this beautiful screen. It is still hard to evaluate from here. You have a lot of parentheses to worry about. Okay, we're going to type in for our bottom bound, alpha A. We're going to type in for our top bound, alpha B. So again, I don't have to keep track of all of those decimal places. And now you have to be very careful with your parentheses. Notice all the parentheses I have shown right here. You should have that many parentheses when you're doing this, and you're even going to get more because it's going to bring up a parentheses for that cosine. Okay, so we're going to type in open parentheses. There already is an open parentheses. We need 2 of them there. So we have open parentheses, cosine of x. So now we have open parentheses, cosine of open parentheses x. We need to close the parentheses on the x, close the parentheses on the cosine, and then square that. So that's that first portion. So cosine of x, that whole thing squared, minus open parentheses, x squared, close parentheses, squared. And then the final big parentheses is already closed. And you could just write minus x to the 4th if you wanted. I just like to make sure we understand how to do that. And then again, we're just going to type in with respect to x. So a dx there. And then we're going to press enter. And it's going to give me the value of that integral. So the value it just gave me, let's see if I can move this stuff down. Oh, not really. Okay, so we'll just adjust that. The value it gave me was 1.170. And yes, there's a 5 there. It doesn't matter because we're going to truncate. Why is that number wrong? Does anyone know? Why is that number wrong? It's really close. But
There's
why
no
is it wrong?
pi.
There's no pi. Don't forget you had this pi out in front here. Okay, that is the thing a lot of students forget. They forget to multiply the pi because they're just focused on the integral. So we have that thing multiplied by pi. If we have a calculator, your reader wants you to actually do that multiplication. So you're just going to take that number and times it by pi, and you should get 3.677. Again, we got to skip taking the integral of this by hand. We got to skip plugging in all those values and subtracting them. Also, we actually can't take this integral by hand because you would need u sub because of that cosine x squared, and the u sub doesn't work here. So we need a calculator on this question. But again, the first 2 points come from the setup. If you don't have the setup right, the calculator doesn't matter at all. Okay. Any questions on this one? Okay, so let's talk if you have the other one with the other programming. What came up for you was fn int, I think, Charlie, is that right?
That's right.
Okay, so it's going to be a similar thing. We're going to type in our function first, comma, with respect to, and now we're going to go like our bottom bound and our top bound. So filling this in, we would have, in your case, cosine x squared minus x squared squared with respect to x from A to B. Okay, any questions on this?
I have a question, but it's not
Go ahead,
necessarily
Carlos.
like what type of problem would this be? Would this be like an MC or would it be an FRQ because of how long it was?
It could be either place, Carlos, honestly.
Okay.
Depends totally. I've seen this in both of the sections on the test. It's a good question. If
Cool.
it's FRQ, there's a lot more points available. And so the setup is even more important there. If it's MC, just the answer is really all you get points for. And so it kind of sucks because it takes a long time, right? But it doesn't take as long as if you had to do it by hand. So other questions? Good one.
Thank you.
Other questions? Okay, so I was really ambitious and thought we'd get through 5 more problems. That's funny and cute. Oh, actually go back to, I stopped sharing, but go back to the original part, this part, and let's add that information. So intersection points, that's also a second trace or a second calc, however you want to remember that. I know I say it both ways because that button is the same button. And then definite integrals is math 9. This would be a really important thing for you guys to like have. Obviously, there's more information for each of those and how to find them, but I think it's really helpful to have that somewhere in your notebook. And again, I recorded this, so I'm going to post this on YouTube later so that you guys will have a chance to review